We already did the Bohr-Rutherford diagram for oxygen, but now we want to think about its ion. So when I look at the one we drew before, this is our normal Bohr-Rutherford diagram. This is the one we drew earlier. And if you look at it, you'll notice it has 1, 2, 3, 4, 5, 6 in the outer orbit, which means it's got 2 spaces. So for this atom to become stable by filling its outer orbital, it either has to gain 2 or lose 6. And we can tell it's going to gain 2, right? That's a much easier thing for it to do energy-wise, because it's not like it can decide what to do, but it's all about the energy available, and it takes less energy to gain those 2 from something nearby it than to try to lose 6, because it can only lose them to something else and it can only gain them from something else. So that takes energy. So the middle won't change because the nucleus doesn't change. It's still 8 protons and 8 neutrons. That will not alter at all. It will still have both of its orbitals, 1, 2 orbitals, because in this case, we're going to fill those 2 spots. Now remember, those electrons do come from somewhere. They're not coming from nowhere. They're coming from an atom that this has come in contact with that wants to get rid of its electrons. So instead of just doing the original 6, I'm going to fill in those extra 2. So it's gained 2 electrons. Remember, each electron is a negative, so that means this will have a charge of -2. Now, typically, we want to be able to tell that this is a plane atom and this is an ion. So to do that, we actually tend to do this. We put it in square brackets like this, because what the square bracket is saying, hey, this is an ion, and then we give it a charge. And in this case, it gained 2 electrons, so it has a charge of -2 because it has 2 extra negatives. Now, if we look at something like aluminum, aluminum is going to be a little different. We drew aluminum earlier, and you'll notice it only has 1, 2, 3 electrons in its outer orbit. So it has 2 options. It's going to lose those 3, or it has to gain another 5. It's not going to gain 5. That's a lot of energy. It will lose the 3. So the middle, remember, will stay the same because it's not getting rid of protons or neutrons. Its nucleus is stable. So it still has the 13 protons and the 14 neutrons in the middle. So we put those in. Now in this case, we're not going to draw all 3 of the original orbits because we're going to get rid of the 3rd orbital. So we're just going to draw the 1st orbital and the 2nd orbital because we're assuming those electrons, those 3 electrons in that 3rd orbital have been given away to something like oxygen that wanted them. So 2 in the 1st, and then our 8 in the 2nd. There we go. Again, this is now an ion, so we want to say, hey, this is an ion. So we'll put square brackets around it to say, hey, I drew an ion. And in this case, I lost 3 electrons. When I lose 3 electrons, remember, I didn't lose any protons. So now I have 10 electrons and 13 protons, which means I have 3 extra protons, and protons are positive. So this will have a positive 3 charge. I know it seems strange that you lost something and became positive, but that's, remember, it's just the balance between negative electrons. Those are the only things you can get rid of or add, and the positive protons in the nucleus.